Hello guys, today we are going to solve random Leetcode problem from easy random question from Leetcode. So let's randomize first so that, yeah, okay, let's solve this one. I haven't submitted yet, so this is my first time seeing this question. Let's try to solve this problem. So I'm going to read the question. You're giving two binary trees root 1, root 2. When you put one of them to cover the others, some nodes of the two trees are overlapped while the others are not. You need to merge the two trees into a new binary tree. The merge rule is that if two nodes overlap, then some nodes value up as a new value of the merged node. Otherwise, the null node will be used as a node of the new tree. Return the merged tree. Okay, it's a tree problem. The merging process must start from the root nodes. Alright. Let's see the example here. So giving two node from a root, we need to merge it, and then when we are merging it, we need to add up the node. Okay, and then whenever I see. Okay. Okay, how do we go about? So I understand the problem. I just need to construct a new tree and then return it. Okay. So I guess we can iterate through the array. Return it. So, yeah, okay, I think I got the solution where, so we can iterate so we can, in order to traverse a tree, we can use a recursive function, maybe in order, pre-order, whatever order we want to traverse the tree. We could just pass the two node in to separate function, maybe helper function to traverse the tree, and first one would be 1 and 2, the root node. And then if two of them exist, then we can just simply add up and create the new tree node, and then that will be a node. And then we go to the next one. Let's say this is pre-order, so or in order. So we will go to 3, check if there's anything. We're just going to, yeah, both of the node exist in the same order, same level, and then same side. So we're gonna add up the node. It will be 4. So construct node 4, and then connect to the parent side. Somehow link it together. And then we're gonna go down 5, but 5 on the tree 1, and the left side on the tree 2. But tree 2 doesn't have that node, so in that case, it'll be null. So if one of them are null, then we're just going to simply use the other node value and then construct a new tree node and then reference to that. And then somehow link it together and so on. If both of the node becomes null, and that's when this traversing should end so that it will go up. So let's say 5 and then we go left, both of the node will be null. In that case, we're just going to return it. So that's the timing where we need to terminate the recursive function, and then we're just gonna keep going forward with that. Okay, sounds good to me. So it's always good to start with pseudocoding it, so I'm gonna pseudocode that. So in order to traverse a tree, we just need to create the function, helper function maybe. And code, we're gonna pass in root 1 and then root 2. And then in that helper function, what we're going to do, so we need to first, so we will add up the node. So this should be parameter as a node 1 and then node 2, right? And if node 1, the value is node 1 is not null. Okay, if one of the node 2 is null. Pseudocode, so I will use pseudocode language. Node 1 or node 2 is null, then I'm just gonna create the values equal to whatever node. So in this case 5, and then this will be null, so we will use 5 as a value. So this will be 5 in the example 1 in this level. So whether null value is not null, and then if else, we're gonna add up the node 1 value and node 2 value. And then termination of this helper function would be if both of them are null. Node 1 and node 2 is null. Because if both of them are null, then what can you do? You don't want to go down further down. It will be stack overflow. So we just wanted to terminate the function, recursive call. So we're going to terminate that, and then, so that's a termination condition. So we're just going to simply return it. We need to think about the return type later. We'll think about it. Maybe void is fine, but let me see. So yeah, whenever we finish retrieving it, we just gonna we need to create new tree node, which is going to be new node is equal to new tree node with the new value that we just came up. And then afterwards, we would like to call this function again. Yeah, so helper, and then we will call node 1, node 2 of left. If not, no. So yeah, we definitely need to check null value here, because if one of them are referencing to null, then it will throw null pointer exception if you do dot operator here. So we will check that. If both of them are not null, we can just simply call this. But if it is, then yeah, we will check that in the real code. So helper, we will call that, and then we also need to call like similar function here down here. We will call right and right. Okay, so new node is created. We're gonna call both of them, and somehow we need to connect this new node to the parent node that previously created. As I said, so if you're in the 3 and 1, add it up to 4, but we still need to link these to this parent. Parent 3's left child will be 4 or something like that. So we somehow need to do that. How do we go about doing that? One way of doing that is simply by passing it as a func into the parameter. So we can just pass in parent, and whether we want to. So because this is binary tree, we can add left or right. So we need to detect that somehow. So we can just simply like pass in Boolean value if it is left or not. If you want to add to the left, or if you want to add to the right, or whatever. So yeah, we can do that. So in this case, we want to pass in this new node as a parent, and new node as a parent, and it's left. It will be true, right? False. And then we need to, if is left, then we want to add to the parent dot left is equal to new node, and else we want to add to the parent dot right of the new node. So in here, what we're doing is in this parent node, let's say 4. So newly created 3 and 1, the 4 would be the new node, and then parent would be 3. So in this case, if left is true, then we're just gonna add 3's left children is 4, and so on. So that's the one condition there that we're adding, and then yeah, afterwards we're just gonna simply traverse the tree and then repeat the same process over and over again. If I'm not missing anything, then that should be fine. Here, we need to do something here. We can just create the dummy node here. node here, tree node, like 0 or something, and then we need to return the new root, right? So in that case, we can just simply do true, and then we can just simply return dummy.left. So what I'm doing here is creating the dummy node where, so this will be in a new node, 3, right? 1 plus 2 will be 3. But the first function call don't have any nodes, parents. So what we are doing is create the dummy node, new dummy node here, and then and then the 3, the new node, the new root will be connected to dummy node's left side. So we can just simply return this after calling the recursive function. So that's what we are doing right there. Okay, so I think if I'm not missing anything, this should be the answer. So let's code it up and then see if this would work. So tree node, we need to create this. We'll call dummy. We're gonna use same variable name, so it'll be 0. And then we're gonna assume that we have this helper function here. So root 1 we need to pass in, and the root 2 we need to pass in, and parent, and then we're just gonna say true here, and then return dummy of left. Okay, and then we just need to create helper function here. The return type will be void because what's the point for returning the root anything? Actually, we don't really need to create tree node, right? If we can return the new node value. That is true. We don't really need to do this. Right, yeah, we don't really need to do this. We can just say simply return here. And then make this as a tree node to return. Call helper. And what I can do is just simply return tree node, the new node that is being created. So that, yeah, we don't need to do the extra step there. That is great. So, okay, tree node, node 1, tree node, node 2, and tree node of the parent. Do we need to call parent? We can construct the tree and pass in, pass in, pass in. 3 will be left. Yeah, we don't really need to have this parent node too. All right, my thought is all over the place now. Yeah, we don't really need that too, because if we think about it, 1, 2 is going to be pass in, and then we're gonna create new 3, the node 3, right? And then when we are calling 3 and then 1, we're gonna create new node of 4, and then we keep going till the end. 5, and then nothing. We add up to 5, so we're gonna return it, right? And then at this point here, when we get back to this point, whenever we finish calling on left side will return the new node of 5. So we can just simply add the parents where we are currently in. 4 dot left will be 5. So 4 dot this tree node dot left will be 5. So yeah, we don't really need to have that. Okay, my thoughts is everywhere. All right. Okay, at least we figured out the cleaner way of doing this. So this pseudocode wouldn't be that useful anymore, but okay, whatever. Node 1, ooh, this is pseudocode. Node 1 is equal to null, and node 2 is equal to null. In that case, we just gonna return it. In that case, we're gonna return null, right? Yeah, we can just return null in this case. And then, and here, yeah, we need to create the value here will be 0 initially, and we need to, I'm trying to find a cleaner way of doing this. Okay, we can just do. We can just do something like val plus equals to if tree node. Oh no. Node one dot node one is equal to null. If it is null, then we're gonna add 0 to it, and if it's not null, then we can just add value to it, right? So we can just do that for both of the side, node 2 as well. Make sure copy and paste is dangerous sometimes. We forgot to change these 1 or 2. And then the value be the right number, so we can just construct a new tree, new node. Okay, let's do that. Value be this. And then we are going to call helper function here. I'm trying to create this. So because we need to be careful about the no pointer exception, if node2 is null and then try to pass in node2.left, we will have no pointer exception. So I want to avoid that. But writing a bunch of if statements, it will make the code messy. So I'm going to write code in a way that it's not going to get messy. So tree node left, left one will be node. Is going to be equal to node 1 dot left is equal to no. If it is, then if it is no, then we can just say no. And if it is not, then we can just do that. All right. So and then we have to do the node 2 as well. In this case, we can just simply call helper now. Helper of left 1, left 2, and that's about it. And then whatever new node is being returned from the left side, we want to add it to the new node dot left will be the whatever that is being returned, and new node dot right will be whatever that we're getting being returned here. Yeah, we also need to do the same thing for right side too. Ooh, this code is not that clean, but I guess it worked, right? Hopefully. If it doesn't work, then I suck at it. Oh my god, it's a lot of fix. Right, right 2, right 1, node 1 right, node 1 right, right 2, node 2 right, node 2 right. Okay, seems good. Okay, so node right, we need to go right 1, right 2, and so on. And then we're just gonna return the new node here. So since we're returning new node, let's say we are in here, right? Number 4. So we just constructed the new node, and then we're calling the left helper left. So in this case, it will call 5 and null. It will call that 5 plus 0 is will be 5, so new node will be 5, which is in here. New node will be 5, and then we're gonna call left again. And then being called left, both of them are null, so it's being returned, and then 5 will be here. We're gonna call right, both of them are right, null, so we're gonna be returned. And then 5 will be a new node that is being returned to the previous node. So 4's left, the 4's left is going to be 5. So no, this will return 5, and then this will return this one, whatever this one is, so 4, and so on. So hopefully this should work. Let's try it out. First time, usually my code doesn't work. Oh, well, yeah. Okay, careless mistake. Let's not do that. I will fail if I do this in the coding interview. So let's check. So root 1, root 2, pass in. I'm just going to simply pass in, and then if both of them are null, return null. Value. If it is null, then we're going to add 0. That is true. The value would be that. Left 1, left 2, right 1, right 2. If it is null, then we are going to be null. Yeah, seems good to me. Ah, my God. No pointer exception? Oh my God. I am so done. Yeah, we tried to avoid no pointer exception, but intentionally creating no pointer exception here. That was not a good idea. Okay, good. So first example solved. Let's let's try out the test case here. The second example. It's taking a while. Um, didn't expect to solve this pretty long. This is easy Leetcode, but easy Leetcode is not easy, to be honest with you. Okay, seems like it's working. Hopefully it will work in the first try. Let's see. Okay, looks good. The memory usage is not that good, but I usually don't care about memory usage, to be honest. Um, and then yeah, runtime is 100%, so looks pretty good. So this is would be of n times, I believe. So recursive function, because we are calling it recursively, we need to visit every node. So the the space complexity would be the number of nodes. It will be, I guess it will be n plus m, or just O of n. And then the time complexity would be the same because we're visiting every node, right? So it'll be the maximum node of whatever whatever tree that has maximum number of nodes, and then it's goes same with the space complexity. Maximum number of nodes would be the complexity. Okay, so let's see the solution. Thank God that we don't need to pay to see the solution. I think this will be the solution. Oh, this is a lot cleaner. What the hell? If it is null, then return. Oh, that is true. This is a lot cleaner. T1 is null, then just. Alright, yeah, I learned a lot from the solution actually. Writing clean code. Wait, what if? Oh, okay, I see. Return, but we still want to traverse. Wait, why is that so? Because if t1 is equal to null, we're just going to return t2. But t2 might not be null, but t2 might have a lot of children. In that case, do we want to return? Wait a second. Let me see the solution here. Not solution, I mean problem here. Interesting. I need to figure this out. Okay, so yeah, it seems a little off to me because T2, if T1 is equal to null, T2 might be a null or not null, who knows? But T2, if the T2 is not null, why are you returning? So okay, let's read entire solution actually. Left T1 dot left, T2 dot left. Whatever being returned, it will be left. All right, T1. Oh, okay, yeah, that's true, that's true. What am I talking about? Yeah, that is true. We can just simply reference to that. Okay, I see. Because if it is null, then T1 don't have, um. All right. Okay, this is clever. This is pretty good solution. All right, so yeah, today we solved. Okay, I figured out the solution. That's great. That was a really clean code. I should learn that a lot from that. But yeah, today we solve. This is actually the problem from easy top 100 like question. Number 617, merge two binary trees. it was pretty basic question for traversal, but as I said, as you saw, I run into two problems where forgot the parameters and tried to change the parameters after changing it here, and then yeah, forgot to do a dumb mistake. So I really should be careful writing the code first, and then yeah, it could have been really cleaner code than this one. So that's where I need to practice, I guess. So yeah, today's lesson is there's a lot cleaner way of writing code, and yeah, just it was a really good review for you know going over how to traverse tree using recursion. Thank you for watching.